Hi, my name is Rachel, and today I would be presenting the digestive, urinary, and reproduction system. I would be going over the functions of each system and the structures for each of them. The first system that I would go over is the digestive system. The digestive system word is broken down into two, which is apart and to carry. The digestive system's function is mainly used for food, in which the food is broken down into molecules to enter body cells. There are two groups of organs that make up the digestive system. They are the digestive canal, or gastrointestinal tract, and the accessory organs. The digestive canal's function is to hold food in the digestive tract from the time it is consumed or until it is digested, absorbed, or eliminated. This can be helped with the muscular contractions. The muscular contractions can break down the food by being physically churned along the digestive canal from the esophagus to the anus in the wall of the digestive canal. It also dissolves food by mixing with fluids. The accessory organ's function is to chemically break down food using enzymes with the help of cells that line the digestive tract. They also take part in ingestion, secretion, mixing and propulsion, digestion, absorption, and defecation. Moving to the head and neck structure, there is nasal cavity, nasal conchae, hard palate, nasopharynx, oral cavity, tongue, oropharynx, laryngopharynx, and epiglottis. Moving to the upper abdomen structure, it consists of the esophagus, stomach, duodenum of the small intestine, pancreas, sphincter of Oddi, liver, falciform ligament, left lobe, right lobe, common hepatic duct, gallbladder, common bile duct, and spleen. If we were to open the stomach of the digestive system, it would consist of a cardia, fundus, body, pylorus, and to elaborate on that, the cardia prevents stomach content from coming back up, the fundus stores gas from digestion, the body digests the food, and the pylorus prevents intestinal content from re-entering the stomach. We also have the greater curvature, lesser curvature, pyloric sphincter, cardiac sphincter, and rugae. The digestive system in the lower abdomen structure includes the jejunum, ileum, ileocecal valve, cecum, appendix, ascending colon, transverse colon, descending colon, sigmoid colon, and rectum. The supplemental structures include the caudate lobe of the liver, the quadrate lobe of the liver, hepatic portal vein, and hepatic artery. Next, we have the urinary system, in which the purpose is to remove waste from the blood in the form of urine. The frontal view of the kidney structure consists of the renal capsule, renal cortex, renal medulla, renal pelvis, renal artery, renal vein, renal column, renal pyramid, renal papilla, and renal calyces, minor calyx and major calyx. And when using the frontal view of the kidney enlarged, we have the segmental artery, interlobular artery, arcuate artery, and interlobular artery, interlobular veins, and segmental veins. When looking at the full view, we have the adrenal gland, kidney, ureter, and urinary bladder. When we take a closer look at the bladder, we have the detrusor bladder, the trigon, the ureteral openings, and the prostate gland. Lastly, we have the supplementary structures, which includes the urethra and prostatic urethra. The reproductive system function specializes in sexual reproduction, and males and females have different anatomical structures. So for the anterior view of the complete female reproductive system, we have the ovary, the ovarian ligament, and oviduct, which is the fallopian tube. Next, we have the lateral view of the reproductive system for the female. So we have the ileum, the piriformis muscle, and the internal obturator muscle. And when we remove the organs and face the reproductive system in the anterior view, we have the sacrum. And in the inferior view, for the female reproductive system, we have the labia minora, the labia majora, the sarcotuberous ligament, and the sarcospinous ligament. We also have the levator ani muscle. In the superior view, we have the broad ligament, the round ligament of the uterus, the ureters, and rectouterine fold. In the sagittal view, we have the vagina, the uterus, and the cervix. In the sagittal view, we have the urogenital diaphragm, the external anal sphincter, and the internal anal sphincter. So moving on to the men, in the anterior view, we have the penis, the corona, the scrotum, the spermatic cord, and the ureters. In the sagittal view, we have the corpus cavernosum, the corpus spongiosum, the bulba penis, the fundiform ligament, the spongy urethra, the membranous urethra, the bulbourethral gland, the prostate gland, the urogenital diaphragm, the internal anal sphincter, the external anal sphincter, the levator ani muscle, and the obturator internus muscle, the prostatic urethra, and the ejaculatory duct, and the scrotum. In the sagittal view, we have the prostatic urethra and ejaculatory duct. In the penis and testicle, we have external membrane, the tunica dartos, the fascia spermatica externa, the cremaster muscle, the fascia spermatica interna, the testes, the epididymis, and the ductus deferens. So how did they relate exactly? So they relate to several ways, such as hormonal regulation, metabolism and nutrient utilization, pressure in space, waste elimination, pH regulation, and blood flow and oxygen nutrient utilization. Oxygen supply. Going into each of these topics, hormonal regulation can affect all of these systems because the hormones that are produced by the reproductive system can affect the urinary system and hormones from the digestive system. For example, insulin from the pancreas, which can impact the metabolism and overall health. Metabolism and nutrient utilization comes from the digestive system, which can support the functions of the reproductive and urinary systems. Pressure in space is also related to the urinary bladder and all of the other systems because the urinary bladder is positioned closely to the reproductive organs, and as the bladder fills with urine, it can exert pressure on the reproductive organs. It can be noticeable in pregnant women, affecting the position of the uterus. The pH regulation is relevant to the other system because the urinary system helps regulate the body's pH level by excreting acids or bases. Proper pH balance is important for overall health and can impact reproductive functions. Lastly, the blood and oxygen supply and nutrient delivery are all connected. The right amount of blood supply ensures the right oxygen and nutrients they need for proper functioning of each system. So that is all for my presentation.